Hello and welcome to BlastOne International's tutorial on this particular piece of equipment, which is called an AirPrep. An AirPrep is basically an aftercooler. What an aftercooler does is cools the air as it comes from the compressor into this particular receiver or pressure vessel. So an AirPrep is designed to have an inlet or an accumulation bowl on it. What the accumulation bowl does is it receives the primary air. Any air that's got any moisture in it is vented through this particular valve here. And as you can see, the water dripping out of it. So ultimately, when you start using these machines, the first thing that you do is you leave one of these valves, this valve here, cracked open slightly. Not excessively, because if you open it all the way up, of course, you're losing too much air that the compressor's making unnecessarily. So you've got an accumulator here, the air comes in. So how do we get the air into this thing? Well, primarily there is what we call a bullhose. So the bullhose comes from the compressor. So the best way to do this and to keep yourself safe is to hook this on to the unit first before you hook it onto the compressor. So there's no chance of anybody actuating air through this particular hose, because as you can see, it's quite substantial. Rule of thumb is, with these particular hoses, if you can depress it with your foot or crimp it with your hands, there's no air in it. So if the end's open, of course it can't have any accumulated air in it at all. What I prefer to see on these particular hoses is a double bolt clamp, so 2 bolts. The keepers are on the top. It's got a shoulder on the ferrule, and that pushes down inside. The hose tail goes right inside this particular hose. We also use silicone or Sikaflex to help assist and hold that particular hose in that hose tail. Also, you'll notice in the front of this particular mince-up coupling, so this is called a 2-inch mince-up coupling. In this here is a seal or a gasket. So that gasket on these particular units has got a steel ring in it. So it's somewhat difficult to get it out, but if it's compromised, damaged, not concentric, it needs to come out and be replaced. So what you'll find you'll need to do is you'll need to pry this one out with either a screwdriver or a pair of pliers. So you'll actually undermine the wall or the integral wall of this particular O-ring to remove it. The one thing I would suggest is you use graphite dust when you put the new one in. So you smother the new one with graphite dust because it's a dry lubricant, it's not grease, and won't have garnet or any other contaminants adhere to the lubricant. So by putting graphite dust in, you enable the gasket itself to slip into this particular housing where the recess is. So there's a recess behind this gasket that enables this to push the back of the seal open, balloon into the recess, and doesn't come out easily. It's important you don't leave these hoses open in a dusty environment or dirty environment, primarily because it can accumulate dust and dirt inside this hose, and when you connect it to this particular unit, you're just contaminating the aftercooler fins that are on the top of this unit that we'll discuss very shortly. So it's important that you check these particular fittings, make sure the bolts are done up tight, make sure that the gasket is in good repair, and make sure also that the mince-up clips are square and haven't been damaged or run over. So ultimately, if someone run over this with a truck, forklift, whatever, it's compromised, has to be removed and replaced. Important thing to remember, when you cut these hoses, always cut them square so that the square face edge of the hose marries all the way back to that leading edge on this particular fitting. By doing it that way, you know that it's square and the clamp's got a good chance of getting all the premise of the hose itself clamped and held behind the ferrule that's on the back of this hose tail. So it actually pinches this hose onto a leading edge that is on the hose tail at the end of the hose tail itself. So that 1, 2, and the silicone is 3 types of retention to hold that hose into that fitting. Why am I pedantic about these? Look at the size of the hose and the amount of air that it can carry. Imagine the pressure that's behind this. So if this is compromised in any way, shape or form, it deems it unsafe. And with that comes the fact that you could get hurt. So why get hurt at work? It's crazy. You need to make sure that you have all the appropriate safety equipment. So what also goes with this particular fitting is this item here is called a whip check. So the whip check is spring loaded with the two retaining eyes there, so you slide it back and fit it over the fitting as such. So that then enables me to put it on there. I can leave it on here, like so, until I've fitted it to this particular unit. So when I get it in place, then I can slide it up. Remember, hose whips have to be taut. You can't have it loose with slack, because then it won't do its job. If this came undone and this is slack, it gives it the opportunity to come back and hit you while it's whipping with no restraint. So the restraint here is the hose whip. So this particular fitting's got a gasket, so is the marrying fitting for the mince-up coupling. It has a gasket in it as well. You must check that that gasket's in good repair and hasn't been compromised by damage or wear. With these mince-up couplings, you'll have two holes either side, 1, 2. Those two holes marry with the set that this couples to. So that's why it's called a coupling. It couplings into its partner. I always use 2 pins, 2 safety pins with these particular fittings, primarily because it's twisted to make it house in the seat. And if you don't put 2 pins in, what can happen is, with a twist on the hose like so, and you put air on there, watch what happens to this fitting when I let it go. See, it's just made a quarter of a turn before it's located in the little dog. So even the dogs on the fitting itself aren't enough to hold that in place. So if I move that, see what happens? It just falls off. So basically what you'll do is put it on like so, and if there's too much recoil required in the hose, go back, appropriate the hose, take the torque off the fitting. You don't want any torque on the fitting, and then put the pin in. Now you can put the pin in either way. You can put it from the bottom up or the top down. The best way to do it is from the top down, because if I put this pin in place with it up like that, then what's happened is it leaves a sharp edge exposed, so that if I have to do anything to the machine, I can actually cut myself open. So the best way to do it is with these pins, is to point the pin down. Now the other thing too you can do is, you're not compromising the pin, but if you're concerned that that might be too sharp or create a problem, there's absolutely nothing wrong with this piece of spring. With another pair of pliers, just bend it round slightly so that it doesn't remain open with the edge pointing out. So I've got no problem with that at all, as long as the pin still maintains that shape and this outer edge marries with the inner edge. So always 2 pins in what we call a bull hose. So that's a bull hose, that's a primary hose that feeds from the compressor, and it always has 2 pins. So they do have the capacity to twist. So you'll find that too, sometimes the pin doesn't line up with the hole, so just turn the fitting around until you get the location of the hole and the pin slides through. So that's one bull hose. Now look at this particular unit, it's got 2 inlets. And always on this unit it'll say inlet and outlet. So the inlet is the primary side, the outlet is the exhaust side. So the primary side is the air in. So all the air that we're getting here is going in and through this particular cooler. Now on this side, say for example I had 2 blasters working and I needed more air, so one 400 CFM compressor wasn't enough for one blast pot. This enables me to put another 400 CFM compressor on this bull hose attachment and run 2 400 CFM compressors into this particular unit. I still need this valve cracked slightly, and then when I've appropriated the other hose, I'll open this valve and I can have 2 lots of air coming into this. This particular unit is a 750 CFM AirPrep. You can get a 250, you can get a 400, you get a 750, you get a 900, and you get a 1200. So in that sizing of those particular units, it does 2 things. One is, it appropriates the amount of air that's required to operate the piece of equipment that's attached on the other end of it. But you have to bear in mind that with that segmentation of sizing comes the aspect of the facilitation of air on the exhaust side of it. So for example, you wouldn't use this 400 CFM pot, or let's say for example, to put it in layman's terms, A number 7 nozzle requires a 312 CFM of air. If you used a 250 CFM AirPrep, you're right on the precipice of how much air that aftercooler can cope with the volumetric air that it consumes to facilitate your nozzle output. So in this case, we can run a 750, two 6.5 cubic foot blast pots quite adequately and still maintain dry air, because this particular unit has got the capacity to adequately condition the air as I drag it off. So what's the big plus with this particular unit? Why would I use an aftercooler? With any abrasive application, moisture is your biggest enemy. Why? Because it can consolidate the grit. It can cause me problems with the automatic aspects of a blast pot and the fundamentals of the valving itself to appropriate the grit out the other side. The beauty of this also is that I can run all my airless equipment off this. It's all dry air, so I'm not making my airless unit susceptible to moisture. So the big plus here is we've got a fan arrangement underneath to draw the air through the fins, and the fins just look like the radiator in your car. That's basically all they are, only you've got air running through them. So the fins give the air pulled through time to cool those particular capillaries and cool them down, pull the air through, and then the air that comes out the other side is cooled right off. Here we have a regulator and an oiler. So what's this for? Well, underneath, as I mentioned, there's a fan. So the fan is pulling the air through the fins on the radiator up top, through the fins, cooling them. So it's important that this is running all the time. So you can see up here, do not exceed 60 psi. So the 60 psi relates to the air motor that's underneath. Why do they put 60 psi as a maximum? Because they've worked out that 60 psi of air running over that air motor is the maximum amount those bearings and the impeller in that motor will take to give you longevity, and also to maximise the amount of air that the fan's pulling through the fins on the cooler on the top. So you've got an oiler here. The oiler keeps the lubrication up to the fan that's underneath, or the fan motor, and the two bearings, one top, one bottom. And the oiler here has a sight glass on top. The sight glass enables me to appropriate how much detergent oil or lubrication I put through the automatic oiler. So what happens is the air comes through and it'll drag from a Venturi system the oil